So here's how I'll get students to work through the problem using pattern blocks. So I'll ask them to build the first equation. So I've got a square and two triangles, and we know that that's worth 16. Then I'll ask them to build the second equation, so two squares and a triangle, and that's worth 11, or equal to 11. Now, one of the key concepts or ideas behind simultaneous equations is this idea of eliminating one of the variables. So at this point, I'll tell students to pick an equation, and we're going to double one of them. Why we double it will become clear in a moment. So let's just choose this left one. If we double this equation here, if I bring in an extra square and two triangles, then this 16 needs to double as well. So that's now worth 32. And then hopefully students can see the reason why we've done that is because now in each equation we have two squares. The difference is we have 4 triangles here compared with only 1 triangle here. So these 3 missing triangles must be the difference between 32 and 11. So these 3 triangles here, if I was to bring them in, that would bring the value of this equation up to 32. Now the difference between 32 and 11 is 21. So these 3 triangles must be worth 21, which tells us that 1 triangle on its own must be worth 7. Now, once we know the value of 1 triangle is 7, the square becomes almost trivial. Then these 2 squares here must be worth 4, so each of the squares must be worth 2.